I am Dr. Chandrashekar BM, Professor and HOD, Department of Chemistry, Bangalore Institute of Technology. And today I will be talking on hydrogen as next generation green fuel. See, we all depend upon energy for each and every activity in modern life. See, for day-to-day activities, for each and every activity, we depend upon energy. We need energy. We use energy in one form or other form. Actually, the quality of the life is measured in terms of the energy consumption. And also economy of a country is also linked to the energy consumption by that particular country. And in case of developing countries as well as developed countries, there is a rapid increase in the consumption of the energy. Actually, in case of developed countries, energy demand is already at maximum, whereas it is increasing rapidly in case of developing countries like India and China. Yeah. Yeah, you can have a look at the global energy consumption. You can have a look at the global energy consumption. You can see here, there is a rapid increase in the consumption of the energy from year to year. If you just in this particular graph, if you see from the year 1980 to the year 2030, the energy consumption is almost increased by 3 times. And this is the projection from 2020 year onwards. And you can see there is a rapid increase in the energy consumption from year to year. And you must know from where we get this particular energy. If you look into the energy resources, from where we are getting this energy, you can see at the bottom here, you can see in the graph also, at the bottom you can see here, whatever the energy we are using today, about 26% of the energy it is coming from coal. And this coal we mainly use in thermal power plant for production of the electric current. And 23% of the energy we are getting from natural gas. Natural gas is also used in the thermal power plants for production of the electric current. And we use natural gas in terms of in the form of CNG, compressed natural gas. And 5% of the energy we are getting from nuclear energy, from nuclear power plants. And 3% of the total energy consumed we are getting from hydroelectric power. And 2% of the energy we are getting from the renewable energy resources like wind energy and solar energy. And 9% of the energy we are getting from biofuel and biomass. And about 31% of the energy, the maximum energy what we are using today, it is coming from crude oil, what we call it as fossil fuel. Okay, these are the energy resources from where we are getting the energy mainly. And these resources, we can classify them into non-renewable sources of energy and renewable sources of energy. I think you all know the meaning of renewable sources of energy and non-renewable sources of energy. Renewable sources of energy are those energy resources which can be renewed continuously. And non-renewable energy resources are those resources which can be used only once and which cannot be renewed. And here, this crude oil and coal sample, they come under this particular category of non-renewable energy resources. Biomass and bioenergy, we can keep on generating it and we can keep on using it. Hydroelectric power also, we can keep on producing the hydroelectric power from the water resources. And wind and solar energy also, they are the renewable source of energy. Nuclear energy, we cannot classify that into either a renewable source or non-renewable source. There are its own advantages and disadvantages of the nuclear, electric power. Okay. And out of these energy resources, we use these energy resources mainly in these 4 areas. We use the energy resources like coal sample, natural gas in the power generation. We use the crude oil resources like petrol and diesel in the transport. We use the crude oil resources and coal sample in the industries for the heating purpose. And also for the domestic heating purpose, we use, for example, LPG we use, and the bioenergy and waste materials from the bioresources we use commonly in India, we use for domestic heating purpose. You can observe one thing here. About 90% of the energy resources what we are using today, they contain carbon. They are the carbon containing materials. Therefore, see these energy resources, we call them as chemical fuels. And the definition of the chemical fuel itself, we define it as a carbon containing material which gives lot of heat energy and light energy on combustion. Okay, therefore, as of today, the energy resources, if you just talk about energy resources are nothing but the carbon containing materials, because the majority of the energy resources what we are using today, they contain carbon, and they emit carbon dioxide on combustion. And the main way of the using of these carbon containing chemical fuels is through combustion. Everywhere we burn the carbon containing fuels. In thermal power plant, we burn the coal sample. In the vehicles, we burn the petrol and diesel, and we burn the furnace oil in the industries. Like that, everywhere we carry out the combustion of these carbon containing fuels. And whatever the heat energy is liberated there, that heat energy is used in different format. It is used in the form of the mechanical energy or in the electrical energy, and different format. Now, out of these carbon containing fuels, majority of the fuels what we use here is the fossil fuels, mainly the petrol and diesel. This petrol and diesel, there are mainly 2 drawbacks with the using of these fossil fuels. See, fossil fuels, they mainly contain carbon, and they emit carbon dioxide into the atmosphere. And not only carbon dioxide, they are also responsible for emission of other oxides of nitrogen, oxides of sulfur, and volatile organic compounds into the atmosphere. And out of these pollutants, see, carbon dioxide, even though it is non-toxic, it is the main gas responsible for the global warming. I think you all know the meaning of global warming. Global warming is the consistent increase in the average surface temperature of the Earth due to increase in the concentration of carbon dioxide in the atmosphere. And majority of the rough weather conditions what we are observing today, they are attributed to this global warming. See, carbon dioxide, it can readily absorb the IR radiation, infrared radiation emitted by the Earth's surface. I think you must be knowing, see, Earth's surface, it is a very good absorber of visible radiation. Whatever the visible radiation we get from the solar energy, it is readily absorbed by the Earth's surface. And to maintain the radiation balance, it in turn emits the IR radiation, infrared radiation. And part of the IR radiation emitted by the Earth's surface, it is readily absorbed by the carbon dioxide molecules which are present in the atmosphere. You all know the structure of the carbon dioxide, C double bond O, double bond O. That vibrational frequency of that carbon oxygen double bond, it is very similar to the frequency of the radiation emitted by the Earth's surface. Therefore, whatever the IR radiation, we also call it as thermal radiation. Whatever the IR radiation is emitted by the Earth's surface, part of that IR radiation is absorbed by the carbon dioxide and re-emitted back to the Earth's surface. And this particular phenomena, we call it as greenhouse effect. And greenhouse effect is actually a natural phenomena. It is a natural phenomena, and it is mainly responsible for maintaining the average surface temperature of the earth, and we are all existing on this earth mainly because of that greenhouse effect. There is no temperature variation, there is no huge variation of temperature from morning to the night time on this earth planet. That is only because of this greenhouse effect. But due to combustion of this carbon containing fuels, we are emitting billions of tons of carbon dioxide into the atmosphere every year. As per an estimate, about 55 billion tons of carbon dioxide is being released to the atmosphere each and every year. And this is increasing the concentration of carbon dioxide in the atmosphere. And presently, the concentration of the carbon dioxide, it has been increased to more than 400 ppm and to around 408 ppm. And this increase in the concentration of the carbon dioxide in the atmosphere, it is increasing the absorption of the IR radiation emitted by the Earth's surface and re-emission of that IR radiation back to the Earth's surface. This is increasing the average surface temperature of the Earth. And this particular phenomena, we call it as global warming. And carbon dioxide is the main culprit responsible for the global warming. Therefore, even though carbon dioxide is not dangerous, this is one of the major danger with the carbon dioxide. Even though it is non-toxic, this is one of the major danger. And therefore, in future, if you want to replace these carbon containing fuels, we need to look into the fuel where there is no carbon to prevent the emission of carbon dioxide and to protect this world from the effects of the global warming. That is one of the major drawback of these carbon containing fuels. And another major drawback of these fossil fuels is they are non-renewable in nature. Whatever the stock of fossil fuels we have today, it may last for another 30 years, 30, 40 years maximum. And by that time, all these petrol, diesel will be completely exhausted. Therefore, we need to find the alternatives to this petrol and diesel. Okay, these are the two main drawbacks of the 90% of the energy resources, carbon containing resources, what we are using today. Therefore, in future, for sustainable development, we need to look for the alternatives. We need to look for the chemical fuels where there is no carbon. And we need to look for the energy resources which are renewable in nature. Renewable and also which do not emit carbon dioxide into the atmosphere. Therefore, so a lot of research is going on about making this world pollution free and also finding the alternative energy resources where there is no carbon and where there is no emission of carbon dioxide into the atmosphere. So if you just imagine a world where there is no pollution at all, where there is no emission of any pollutants into the atmosphere, that particular target, it seems to be highly unrealistic at this particular point of time. But it is possible. See, research and developments in the field of energy, they are happening in that particular direction. And in future, in next 30, 40, 50 years, we may attain that particular goal, and we may move to a world where there is no environmental pollution. And for achieving that, whatever the carbon containing fuels we are using today, we need to shift from these carbon containing fuels into non-carbon containing fuel. And as of today, see, research is going on in finding two different type of alternatives. Again, the one way is finding the alternatives which are similar to petrol and diesel, which contain carbon, but which are renewable in nature. And second way is finding an alternative to the carbon containing fuels where there is no carbon, a non-carbon alternative. So alternatives which contain carbon mainly include alternatives from the biomass, converting the biomass into synthetic gas, CO and H2, and using that synthetic gas in the production of the liquid fuels, petrol and diesel, and converting, principally, whatever the biomass we have. See, biomass is also made of carbon and hydrogen. Fossil fuels are also made of carbon and hydrogen. But in addition to carbon and hydrogen, in the biomass, there is oxygen also. There is extra oxygen present in the biomass. And because of that oxygen, oxygen is more electronegative when compared to the carbon and hydrogen. And because of the higher electronegativity of oxygen, the bonding in case of these biomass molecules, it is highly complex. Therefore, biomass molecules are solid compounds. Whereas fossil fuels, you can just imagine the petrol and diesel, they are the liquids. We use them because they are the liquid fuels. And chemical composition of those fossil fuels, it is very similar to the biomass. But the main thing with the biomass is, in addition to carbon and hydrogen, it also contains oxygen. Therefore, we can subject this biomass into steam reforming. In chemistry, there is a reaction, we call it as steam reforming. Steam reforming, passing of the steam at very high temperature over the biomass using a nickel catalyst. We can convert the complex molecules which are present in the biomass into very simple mixture of carbon monoxide and hydrogen. And that mixture of carbon monoxide and hydrogen, we call it as synthetic gas. And that synthetic gas, in turn, it can be used in the synthesizing of almost all the organic chemicals what we get from the fossil fuels. We can synthesize the petrol, diesel, we can synthesize the various organic compounds like methanol, ethanol, and also almost all the organic compounds what we are getting that can be synthesized in the laboratory, in the industry. And there is a famous reaction, Fischer-Tropsch synthesis, and with the help of the Fischer-Tropsch synthesis process, we can convert the biomass into the carbon containing fuels. And whatever the fuel we get from the biomass in this particular way, we can consider it as a renewable source of energy, because biomass we can keep on generating year by year, and we can keep on using that also. And if you use the biomass, chemical fuel derived from the biomass, then the carbon dioxide concentration will not be increased, because whatever the carbon dioxide is released by the burning of the chemical fuels which are derived from the biomass, that much amount of carbon dioxide was already taken by the biomass from the atmosphere. For example, if you are producing the liquid fuel from the plant by converting the biomass present in the plant into petrol, if you burn that petrol, whatever the carbon dioxide is released there, that carbon dioxide will be equal to the amount of carbon dioxide taken by that plant during growth of the plant. Therefore, in that way, the amount of carbon dioxide emitted into the atmosphere will be nullified. Okay, that is the one way of minimizing the emission of carbon dioxide into the atmosphere with the help of the alternatives which contain carbon and which are very similar to the present day carbon containing fuels what we are using today, but which are renewable in nature. And there is another way of achieving this particular goal, that is using a non-carbon containing fuel. And when we consider a non-carbon containing fuel, the only fuel which comes into our mind is the hydrogen as a chemical fuel. Hydrogen is the only non-carbon containing fuel which can be efficiently used as a chemical fuel, which can be efficiently used as an alternative to the carbon containing fuel. It is an ideal, highly efficient, renewable, clean and sustainable energy resource. Hydrogen can be used as fuel because the energy content of the hydrogen is very high. Energy content of the hydrogen, it is 122 kilojoule per gram. and this is almost 2.75 times greater than the hydrocarbon fuels like petrol and diesel. But compared to petrol and diesel, one of the major drawbacks of the hydrogen as a fuel is its volumetric density. Volumetric density of hydrogen, it is lower when compared to the petrol and diesel. That is another aspect. But the energy content of the hydrogen is very high, and therefore this hydrogen can be used as a chemical fuel in place of the carbon containing fuels. One of the major advantage of using of this hydrogen as a fuel is wherever we use hydrogen as a fuel and we carry out the combustion of hydrogen or oxidation of hydrogen, then the combustion product of hydrogen is water, which is not a pollutant, which is non-dangerous, which is a natural product. Therefore, this is one of the major advantage. We can completely eliminate the emission of carbon dioxide and other pollutants into the atmosphere if we use hydrogen as a fuel. And hydrogen can be used directly for the heating purpose. We can carry out the combustion of hydrogen, whatever the heat is liberated during combustion, it can be used. It can be used in for various applications, like for industrial heating purpose, or for household heating purpose, or for any other wherever we need heat energy. We can directly carry out the combustion of the hydrogen, and we can use the heat energy. And also, hydrogen can be used as the storage resource for the electrical energy. Hydrogen can be used in the production of the electric current. In the previous class, we discussed about fuel cell in detail, and we can produce the electric current in the fuel cell, in the hydrogen oxygen fuel cell, by using hydrogen as a chemical fuel. And these are the two ways in which hydrogen can be used effectively, and where we can replace almost all the energy resources which are coming from the carbon containing fuels, and we can use hydrogen as a chemical fuel. We can use hydrogen as a fuel in the fuel cell for production of the electric current, and that electric current we can use everywhere. And we can use hydrogen as a source of heat energy, and we can carry out the combustion of hydrogen, and we can use it as a source of heat energy. But before we start using hydrogen as a fuel, there are many challenges what we need to overcome. We need to overcome major problems associated with the hydrogen as a chemical fuel. See, one of the problem is the physical characteristic of hydrogen. Hydrogen is a colorless, odorless gas. See, in household applications for domestic heating purpose, we use LPG, liquefied petroleum gas. And if there is any leakage in LPG, we can detect the leakage very easily. But hydrogen is odorless. If there is any leakage in from the hydrogen cylinder, we cannot detect the leakage very easily. And hydrogen is highly inflammable. It catches fire very easily. And hydrogen is highly explosive. And another major drawback of hydrogen is we do not have any primary source of hydrogen. See, fossil fuels, petrol and diesel we get from the earth crust, and in the form of crude oil, and whatever the crude oil is stored in the earth crust, that we are using continuously. But whatever the hydrogen we need to use, that hydrogen we need to produce it. We need to produce the hydrogen. It is a secondary source of energy. We need to produce it, and whatever the hydrogen we produce, that hydrogen only can be used as a chemical fuel. Therefore, what all the amount of hydrogen we need to use, the whole amount of hydrogen has to be produced in the industries, and only that hydrogen can be used as a chemical fuel. That is one of the major drawback of hydrogen, production of the hydrogen. And another major challenge is, we'll discuss in detail about the production of hydrogen, the techniques which are used in the production of hydrogen as of today. The production of clean hydrogen itself is one of the major challenge. because in the hydrogen oxygen fuel cell, we use platinum palladium based catalyst, and the carbon monoxide, if it is present along with hydrogen, it acts like a catalyst poison for the platinum. Therefore, whatever the hydrogen we use there, it should be a clean hydrogen, and production of that clean hydrogen itself a bit problematic. And then other major challenges what we have with hydrogen is the development of whole hydrogen infrastructure. So as of today, the complete infrastructure is built taking the petrol and diesel into consideration. We have petrol bunks everywhere. In each and every part of the city, we have petrol bunk. And to the petrol bunk, there is a well-defined mechanism to supply the petrol and diesel to the petrol bunk. And we have petrochemical industries spread throughout the India. There are a number of petrochemical industries which process millions of tons of crude oil on the daily basis, which produce millions of tons of petrol and diesel, which are transported all over there, from there to the petrol bunks, and from petrol bunk, the petrol and diesel are delivered very easily. Therefore, we can't imagine even a single day without delivery, without this without this petrol and diesel transportation. Everything is very well defined, and everything, the whole infrastructure is very well built. And if at all in future, if you need to use hydrogen as a chemical fuel, then we need to rebuild the whole infrastructure for the hydrogen, for the production of the hydrogen, for handling of the hydrogen, for the transportation of the hydrogen, for refueling of the hydrogen. For everywhere, we need to build the infrastructure, which requires a lot of money. Therefore, these are the major challenges what we have with hydrogen as a chemical fuel. Now, in the development of the hydrogen infrastructure, there are mainly 4 steps here. First step is the generation of the hydrogen, and second step is the storage of the hydrogen, and third step is the transportation of the hydrogen. Then the last step is the application of hydrogen. And for in all these 4 steps, we need to there are many challenges. We need to overcome those challenges, and a lot of research and development activities are happening throughout the world to overcome these challenges in these 4 areas: in the production of the hydrogen, in the storage of the hydrogen, in the transportation of the hydrogen, and in the usage of the hydrogen. Let us see briefly how briefly about these 4 steps which are mainly involved in the hydrogen infrastructure development. First one, the production of the hydrogen. Production, you all know, whatever the method of production we select, we need to consider mainly the environmental impacts, efficiency of the method, cost of the method, the resources what we use there, the availability of the technology, then integration of the system. Those are the options. Those are the main parameters what we need to look into while choosing any method for production of hydrogen. See, currently, whatever the hydrogen we are getting, about 96% of the hydrogen, it is being generated from carbon-containing materials only. See, actually, the main objective of this hydrogen as a fuel, the research and developments which are happening, it is mainly to replace the carbon-containing fuels. But as of today, whatever the hydrogen we are producing, the cheapest way of producing hydrogen is from carbon-containing fuels only. The main resources what we are using today, it is the carbon and hydrogen-containing materials like methane, biomass, the coal sample, petrol, diesel. These higher hydrocarbons are the main source of the hydrogen production as of today. Because whatever the hydrogen which is being produced today, we are not using that hydrogen as a fuel. We are not using that hydrogen as a fuel. We are mainly using hydrogen today in the industrial production. In the industrial production, mainly in the mainly in the very important chemical reactions in the petrochemical industries, and also in the few of the chemical reactions, like in the production of ammonia, production of the methanol. There we are using this hydrogen. And whatever the hydrogen we are using today, it is mainly coming from the steam reforming of natural gas or by partial oxidation of heavy hydrocarbons. You can see the reaction here. See, steam reforming of natural gas by passing steam over the natural gas using a nickel catalyst at 700 to 900 degrees centigrade, we can obtain a mixture of carbon monoxide and hydrogen. And this mixture we call it as synthetic gas. And this synthetic gas, whatever the hydrogen is produced here, this hydrogen can be separated from carbon monoxide, and this hydrogen can be used for any application. So about 96% of the hydrogen what we are generating today, it is coming from the reactions which are very similar to this particular reaction. They are based upon the steam reforming of any carbon containing material, whether it is methane, coal, or biomass, or it can be any other carbon containing material. And there is one more reaction, water gas shift reaction. Water gas shift reaction where CO and H2O by passing H2O over the carbon monoxide with the help of the iron chromium oxide catalyst or copper zinc oxide catalyst, we can convert the carbon monoxide into carbon dioxide and we can obtain the hydrogen. And as of today, the improved version of catalyst for this particular reaction is the platinum, molybdenum, carbon and aluminum oxide based catalyst with the efficiency of conversion efficiency of 44% at 180 degrees reported. These are two methods where the hydrogen is produced from the carbon containing resources. But in future, if at all, if you want to use the hydrogen everywhere and to replace the carbon containing fuels by the hydrogen as a chemical fuel, then there is no meaning in producing the hydrogen in future from the carbon containing resources, because those carbon containing resources will again result in the emission of carbon dioxide into the atmosphere, which is one of the major drawback of the carbon containing fuels. Therefore, to completely overcome the main drawback of the carbon containing fuels, we need to produce the hydrogen from some other source, a source where there is no carbon. Therefore, the only source where there is no carbon which contains hydrogen, it is water. Therefore, in future, if at all we need to shift completely to the hydrogen as a fuel and to achieve the goal of zero emission of carbon dioxide into the atmosphere, to achieve the goal of the pollution-free world, we need to start using water as the source of hydrogen. We can obtain the hydrogen from water by simple electrolysis of water. And this electrolysis of water, it is environmental friendly because the products of electrolysis of water, they are H2 and O2. Only we get pure hydrogen, and that pure hydrogen can be used as a chemical fuel. Therefore, we can produce a clean hydrogen by electrolysis of water. The electrolysis, it is very simple. Dipping two electrodes in the water and passing electric current. At one electrode, there will be evolution of oxygen, where this particular reaction takes place. H2O, it is oxidized to O2 and 4H plus by liberation of 4 electrons. At other electrode, those electrons are used in the reduction of H plus into H2. And this particular reaction, we call it as hydrogen evolution reaction. Therefore, effectively, the reaction here is the conversion of H2O into H2 and O2. Two molecules of H2O split into two molecules of hydrogen and a molecule of oxygen. At one electrode, we can observe the liberation of hydrogen. At other electrode, we can observe the liberation of the oxygen. But the major drawback of this particular method is it consumes highest amount of energy. You can see here the delta G reaction is highly endothermic. See, reaction, it looks very, very simple, splitting of H2O into H2 and O2. But this is the most complicated reaction. It requires a lot of energy. Delta G for this particular reaction, it is equal to 237 kilojoule per mole. Therefore, this much amount of energy is required for production of the single molecule of hydrogen. Therefore, even though technology is available for production of hydrogen by electrolysis of water, as of today, there is no use of this particular technology, because as of today, the majority of the electric current what we are using, it is coming from thermal power plant. Majority of the electric current what we are using, it is coming from thermal power plant, where we use coal as the source of energy, and coal is burnt, and heat energy liberated during combustion of the coal is used in the production of the electric current. Therefore, if that electric current, and we discussed in the previous talk, the electric current what we get from thermal power plant, it is with least efficiency. And if you use that particular electric current for electrolysis of water and production of the hydrogen, then there is no meaning at all. There is no meaning in calling this hydrogen as a clean fuel, green fuel. Therefore, if at all we need to produce the hydrogen by this particular method, electrolysis of water, then whatever the electric current we use for this particular process, it should come from the renewable source of energy, mainly from the solar energy. If we can develop the technology to produce the electric current in a cheaper way from the solar energy, and if you produce excess of electric current from the solar energy, and if you start using that solar energy, that electric current what we get from the solar energy for splitting of the water into H2 and O2, then in that case, that hydrogen can be stored and it can be used as chemical fuel conveniently. Okay, therefore, we need to progress in that particular direction to produce, to utilize the solar energy properly and produce the electric current from the solar energy, and using that electric current for electrolysis of water to split H2O into H2 and O2. Another way, we can produce the hydrogen directly by exposing the water to solar radiation. This particular process, we call it as photo-electrochemical water splitting. Photo-electrochemical water splitting, we use different photoactive catalysts which can absorb the solar energy directly and which can transfer that energy into the water and split the water into H2 and O2. If we are successful in this particular reaction, then we need not use the solar photovoltaic cell at all. We can split the water directly into H2 and O2 by exposing it to solar radiation, by using appropriate the photovoltaic materials directly. In that case, we can produce the hydrogen directly, and we can use that hydrogen as a chemical fuel directly, and we can use that hydrogen in the fuel cell for production of the electric current. We can completely eliminate one step, that is conversion of the solar energy into electrical energy using a solar photovoltaic cell, that we can completely eliminate. And this particular method, we call it as photo-electrochemical water splitting. And a lot of developments are happening to find an appropriate electrode material for the photo-electrochemical water splitting. Many materials like various oxides, nitrides, carbides, sulfides, silicon materials, arsenide material based upon the carbon nanostructures, and organic, inorganic co-catalyst materials have been reported as effective photoelectrode materials anodic materials and cathodic material for this photo-electrochemical water splitting process. But as of today, none of these methods are commercialized because the efficiency of all these materials, it is lower than the expected, lower than what is required for commercialization. An ideal material as a photo-electrode material must have solar to hydrogen conversion efficiency of more than 10%, and stability should be greater than 1000 hours. And what all the materials we have today, none of those materials they meet this particular requirement. Therefore, a lot of research and development activities are happening in all these areas to find effective photoelectrochemical water splitting material. And if you can find that type of material, that will definitely change the way in which we are going to produce the hydrogen, and it will be a very convenient way for production of the hydrogen, and from moving from the carbon containing fuels what we are using today to the towards the non-carbon containing fuel, that is hydrogen as a chemical fuel. Those are the methods of production of the hydrogen. And next major challenge after production of the hydrogen is storing of the hydrogen. So I said in the beginning, hydrogen is highly inflammable. It is odourless, and it is a gaseous molecule. Therefore, storing of the hydrogen itself is a major challenge. Therefore, while looking into the storage methods, we need to consider all these things. A storage method must have good volumetric and gravimetric capacity. It should be a safer method. It should be of lower cost, lower weight, and the kinetics of the adsorption desorption should be very good. There are three different ways of hydrogen storage: gaseous storage, liquid storage, and storage in the solid hydrates. There are its own advantages and disadvantages of all these methods. For example, in case of gaseous storage, it is high pressure method, and the hydrogen storage density is very less, and it requires very high pressure, and there is a chance of leakage, and also cost of storage is very high. And if you go for liquid storage method, there also it requires high pressure condition, but the energy density, storage density is higher in case of liquid storage when compared to the gaseous storage. And we have the chemical species which can store the hydrogen reversibly. Metal hydrates, they come into this particular category, mainly metal hydrates. There are so many other chemicals which are available which can store the hydrogen reversibly, and which can supply the hydrogen whenever and wherever we need the hydrogen. And these methods, they are better when compared to the physical method of the hydrogen storage, that is storing of the hydrogen in the gaseous form under high pressure, and liquefying the hydrogen and storing the hydrogen in the form of the liquid hydrogen, which require a lot of energy. And these methods, they have higher hydrogen storage density and safer method when compared to the gaseous storage and liquid storage, and also they offer higher volume. An overview of the hydrogen storage methods what we have today is given here. So in the physical storage method, we can use compressed hydrogen tank, liquid hydrogen tank. By liquefying the hydrogen, we can store it in the tank, then cryo-compressed tank. And the other way is chemical storage method, which are advantageous. And here, a lot of research is going on about finding the adsorbents and finding the chemical species which can store the hydrogen reversibly. These are the compounds, chemical species which have showed promising results for storing of the hydrogen. One is the metal organic framework, carbon-based materials, mainly nanomaterials, simple metal hydrates, complex metal hydrates, borohydrates, ammonia, borane. So these are the molecules which can be used for storing of the hydrogen. And after production and storing of the hydrogen, next major challenge is with the transportation of the hydrogen. Storage and transport are the most difficult phases in the hydrogen economy. And next major problem will be with building of the infrastructure for transport and filling stations. That is going to be the major challenge. And here in this schematic representation, you can see the main sources of the hydrogen. All these energy resources, coal, biomass, biogas, natural gas, photovoltaic, wind, and hydropower, they all can be used in the production of the hydrogen. And if at all we need to produce clean hydrogen and hydrogen, environmental friendly and green hydrogen, these are the methods which are going to play a very important role in future. The photovoltaic method, wind power, and hydroelectric power, the electric current what we get from here, that can be used in electrolysis of water. And whatever the hydrogen is produced there, that can be stored in the form of liquid in the hydrogen tank, or in the form of the compressed gas, or in the form of the hydride in the chemical species. And that can be transported from one part to other part through pipeline or truck. And there we can use it. Hydrogen we can use it. Actually, hydrogen can be used as a fuel in the hydrogen oxygen fuel cell, and we can produce the electric current on the spot. Therefore, hydrogen can be used as a source of electric current. If you produce the electric current in large quantity from solar energy is available only during daytime, and during night time, when the solar energy is not available, we can store electric current produced from the solar energy in the form of hydrogen by splitting that water into H2 and O2. And that hydrogen can be used as fuel in the hydrogen oxygen fuel cell. And that electric current can be used everywhere. For that electric current, we can use it in transport purpose, for the industry purpose, and also for the household applications. And also hydrogen can be used directly as a chemical fuel. Therefore, wherever we need hydrogen as a chemical fuel, we can use it as a chemical fuel. We can carry out the combustion of hydrogen, and whatever the heat is liberated, that heat can be used as a source of energy. And wherever we need electric current, we can produce the electric current with the help of fuel cell, hydrogen oxygen fuel cell, and with hydrogen as a chemical fuel. The polymer electrolyte membrane hydrogen oxygen fuel cell, it is the most promising the fuel cell which can be used in future for majority of the applications for production of electric current from the hydrogen. Okay, if we start producing electric current in that way from the fuel cell, and use that electric current everywhere, and wherever we need hydrogen as a chemical fuel, if we start using that hydrogen directly through combustion, then we can achieve the goal of zero emission of carbon dioxide. Here in this particular graph, you can see the at what point if the research and developments which are happening in the field of hydrogen progresses in the same manner, at what point we are going to achieve this zero emission of carbon dioxide. You can see by 2060, see almost all the parts throughout the world, different parts of the world, and also different areas in the chemical industries, everywhere we will be using hydrogen as a fuel, and thereby achieving this emission, this goal of zero emission of carbon dioxide. And lot of progress is being made in this particular direction already. So China has set a target of over 1 million fuel cell electric vehicles in service by the year 2030. Even Japan is also progressing very fast. And already throughout the world, there are many technologies where the hydrogen is being used as a chemical fuel directly in the chemical industries, even for the heating purpose, and as well as for the various other chemical processes. Hybrid is one particular project where the hydrogen breakthrough in iron making technology. In the production of the iron itself, in this particular project, they are using hydrogen. And also in Dubai Electricity and Water Authority, it has developed a first solar-based hydrogen electrolysis facility, where whatever the electric current produced from the solar energy, it is directly used in the production of the hydrogen. And also in Mackay Geothermal Power Plant in New Zealand, the geothermal energy, which is also a cheap source of energy, it is being used in the electrolysis of water. These are few examples, and a lot of developments are happening throughout the world in this particular direction, in moving towards the hydrogen economy. Okay, with this, if we can move directly completely from the present day carbon containing fuels to hydrogen. Hydrogen is a green chemical fuel, and where we can completely eliminate emission of carbon dioxide into the atmosphere, and also we can minimize the emission of majority of other pollutants into the atmosphere, where we can imagine a world where there is no pollution. Hydrogen as a chemical fuel, and solar energy as a source of electric current, and fuel cell as a device to produce clean electric current, and these three things together will completely going to these three things are going to completely change our world in future. Therefore, these three things will provide the solution for whatever the problems of pollution we are facing today. With this, I will conclude my talk. I thank you all for your active participation, and thank you all.